I'm going to make it a little bit bigger here in just a minute. Yeah, and the graph paper does get a little glary, so sorry about that. Okay, did everybody get a piece of graph paper? Do we all have one now? He's hoarding it. Okay. So, want to talk a little bit about some basic key features of sine and cosine. Now, together, any graph of a sine or a cosine is called a sinusoid. So basically, these are called properties of sinusoids. So maybe let's write that down. I don't know if they're still alive. Come on. All right, so sinusoid, basically, like I said, just refers to a graph of a sine or cosine of some sort. And so we have these properties, or I guess maybe features would be a better word, of sinusoids. And I think you've probably seen this stuff before, but it's worth going over again. Okay, so I'm going to graph, I'll just do something that kind of looks like a cosine here. Bless you. Okay, so maybe it looks something kind of sort of like that. So the first thing we'll take a look at is amplitude. Okay, so the amplitude of a wave. Anybody remember what that refers to? Or where, on the graph, I can measure that? Yeah.
Distance from resting point to the crest of the wave.
Ooh, yeah. Very physics-like in your answer there. Yeah, so from the resting point to the crest of the wave. Basically, if you were to draw, and in this case it's the x-axis, but if there's a midline through the middle of it, it's how far above that midline or how far below that midline it goes. Yeah, so I'm going to say distance from midline to the max or min. And on a graph, like in this case, your amplitude would be like right here. We'll call it A. All right. Period. So what does the word period mean? Like if something happens periodically, what does that mean? At a regular interval, right. Okay. So period refers to something happening at a regular interval. And so for a sinusoid, that would be how long or how far on the x-axis it takes before it repeats itself. Okay? And the easiest way to measure period when you're looking at a graph is from maximum to maximum or from minimum to minimum. Okay? So in the case of this graph right here, minimum to minimum would be the easier way to go. So yeah, that would be your period then. So I'm going to say distance for one complete cycle to happen. And like I said, you could go min to min or max to max, however you want to do that. That's how you can measure the period. And we don't have just one little letter like the A for amplitude for period. We'll talk more about that later. Okay, phase shift and vertical shift are the other two. And these are just like what we've done before, okay? A phase shift is basically just a horizontal shift like we've done before. And a vertical shift is, well, a vertical shift. We've done those before too, right? Yeah. Sure, yeah. Wavelength is the same thing as a period. Mm-hmm. So, yeah, so vertical shift, I know this is kind of silly, but I'm just going to write vertical shift. Because we've done vertical shifts before, okay? So it's basically just how far up or down it went. Phase shift is a trig way of saying horizontal shift, how far left and right it went, okay? So, do you see here, though, how amplitude, period, phase shift, vertical shift are all each related to one of those different transformational things we've done in the past? Amplitude is basically like a vertical stretch or shrink. Period is a horizontal stretch or shrink. Phase shift is a horizontal shift, and vertical shift is still vertical shift, okay? So, the thing about this is you can write an equation of a trig function if you know all four of these and there's just like a different little place you plug the numbers in and boom, 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 and you got it. Okay? So like for example, or not for example, the general equation for that looks like this. And I'm going to use cosine as an example, but it could be a sine as well. So it'd be something kind of like that. Zoom that in a little bit. It's getting kind of small. So A cosine B times x minus c plus d. Where A is the amplitude. And then be careful with this one. 2 pi over b is the period. C is the phase shift. And D is the vertical shift. Alright, so let's talk a minute about this little period thing here. So why is it 2 pi over b is the period and not just b is the period? Well, a regular cosine that has nothing done to it, so it would just be f of x equals cosine x. What's the period of that? Yeah, 2 pi, right? A regular sine, a regular cosine with nothing done to them at all, their period is 2 pi. Okay? So if I take a number and I multiply it inside, that is a horizontal stretch or shrink, right? And let's say b was 2. Okay? So if b is 2, is that a stretch or a shrink? Remember, on the inside, everything's opposite. So is multiplying by 2 a stretch or a shrink? A shrink. So if the period was 2 pi, what's the period now? pi, right? It shrunk by a factor of 2. 2 pi divided by b, right? If b was 2, the new period is 2 pi divided by 2, which is pi, right? Okay, what if b was 1/2? Stretch, right? What's the new period? 4 pi. 2 pi divided by 1/2, new period, 4 pi. Okay, so it's not a direct, hey, b is the period. It's 2 pi divided by whatever that number is for b. Okay, so we're going to do a little bit of, like if I give you the amplitude, the period, the phase shift, the vertical shift of some sort of trig function, can you then take that information and sketch a graph of it? Okay, or if I give you the graph, can you then off the graph tell me the amplitude, the period, the phase shift, the vertical shift, and then write an equation for it from that? Okay, so I'm going to start with, let's just do an equation and see if you can tell me amplitude, period, phase shift, vertical shift. And then if we can do that, we're going to practice graphing that thing too. That's why we got the graph paper here. Okay, so let's do this one. F of x equals 3 cosine 4x plus 1. Okay, so let's see if we can identify these 4 things then. So just looking at the equation there, what is the amplitude? 3. Okay. Start with this. What's b in that equation? 4. b is 4, so what's the period? 2 pi over 4, which is 1/2 pi, or pi over 2, however you want to say it. Yeah. So our period, I'm going to go with pi over 2, but yeah. Okay. Phase shift? None. So 0. And my vertical shift? 1. Okay. I'm going to pass out a worksheet to you guys. Well, it's not a worksheet. It's just a little thing to put in your notes later that kind of restates step by step what I'm going to do next. Okay. So for this next part, just kind of see if you can follow with me. Go ahead and draw it and everything too. But just know you're going to have a sheet that's going to have like step-by-step instructions for how you do this next thing, because it is kind of a bit of a process that you have to do to graph these things. So have somewhere close to you those graphs we did yesterday, the sine and the cosine graphs, because we're going to reference those to help us graph this thing. All right, so if we're going to graph this, the first thing that we need to do is we need to set up our scale, okay? And our amplitude is 3, okay? So that means that this thing is going to go from its midline, wherever the middle is, it's going to go up 3 and down 3. Up 3 to get to a max, down 3 to get to a minimum from that midline, okay? But where that midline normally sits on the x-axis, the vertical shift will affect where that is then. Because remember, a vertical shift takes an entire function and moves the whole thing up or the whole thing down, depending on what it is. Okay? So if you want to know where's the middle, where's that midline going to be, just look to your vertical shift. Okay? So where's it going to be for this one? Up at 1. Okay? So that's where we're going to start here, is graphing that midline on there and then using the amplitude from there. So, and what I always do for the midline is I make it a dotted line. So we're up 1. And that's where that kind of home base is, where this function should keep crossing that line with that position in the middle. So there's 1. Okay, the amplitude is 3. So that doesn't mean you go up and down 3 from the x-axis. It means you go up and down 3 from this. Okay? So all the maximums should be how high? Up at 4. So I'm going to go 1, 2, 3, 4. And then I always just do kind of a light line here. Just so I know, okay, when I get to all my maximums, they're all going to be sitting on that line. And then where are the minimums going to be? -2. So, same thing. So what we're doing here is we're kind of creating a bit of a corridor, so to speak, that the wave has to sit inside of. Okay? So I don't know exactly where the wave is going to be as far as like, shifted left and right and all that, but I know it's got to be caught in here somehow. It's going to go max to min, caught in there, and this is the middle that it's going to keep crossing through. Okay? Now, here's where the graphs that we did come into play. Cosine normally starts where? Up at 1, at a maximum, right? So, I'm going to start this thing on the y-axis at a maximum. So where should that be then? Where's that point for this one? It's just up at 4, right? Right here. So I know that point's on my graph. It would change, though, if I had a phase shift. Because remember what a phase shift does is it moves it left and right, correct? Okay. So I call this kind of like your anchor point. This is your first point from which everything else is going to come. So because there's no phase shift, this one's good. I know I got it. But if I did have a phase shift, let's say I had a phase shift of like pi or something, then I'd have to move it over a distance of pi and then keep going from there. Okay, and we'll do another one like that in a little bit. But for this one, I didn't do a phase shift just to kind of keep it simpler. Okay, so now we need to use the period to help find another point that's going to be up on this maximum line with this one. Okay, so our period is pi over 2. So that means once I go a distance of pi over 2, I should have another maximum, right? That's what's one way we could measure period, right? Is from the max to the max. So I should have another maximum after pi over 2. And then going negative, same thing. After I go a pi over 2 this way, I should have another maximum over there. Now here's the thing. I can make my x-axis have whatever scale I want. So that this is easy to see, okay? So if your period is pi over 2, if I made every box like pi over 4 or something, that wouldn't be a real good choice, right? Because then you're covering a full period in 2 boxes. So if we got a pretty small period going here, right? Pi over 2. So spread that thing out. Make what you're counting by something really, really small. So maybe, I don't know, pi 16ths? Okay. So then after, be 1/16th, that would be an 1/8. So after 4 boxes, we'd be at pi over 4. And then after 4 more, we'd be at pi over 2, something like that. That seems reasonable. So then our next maximum is going to be right there. Okay, and so I'll go the other way. 1, 2, 3, 4. So here's negative pi over 4 on my x-axis. 1, 2, 3, 4. There's negative pi over 2. Okay, so now I've got some scale going. And this is uber important for those of you guys that don't like to write the scales on the x and y axes for these. It makes all the difference in the world. So got to have something on there. And you don't have to mark every box. Like we said, we can count pi 16ths every box maybe, but you don't have to sit here and write every 16th down. Like what I have right here is perfectly fine. Okay? So what this allows us to do, though, is then I can keep putting some more points on. So if I go back a period, That's going to put me at another maximum right there. Now, if I know where the maximums are, I can start to kind of piece together everything else, right? The minimums, if you look at the symmetry of your cosine wave you graphed yesterday, the minimums should be halfway in between the maximums, right? So where do we have minimums on this graph then? Pi over stupid. Have you guys ever seen Office Space? I want to do to that chair what they did to that printer. Anyway, okay. They watch the movie. So now I can also, like right now, you can kind of start to see where this wave is going to go, right? Now to kind of better click it into place, the midline, you should have points on the midline halfway in between each of the maxes and the mins. So you can plot some points that way too. So I know I'm going to hit the midline here, and here, and here, and here. Okay, so it just kind of gives you some more points to go on. Now, when you actually connect the dots here, please don't make it a bunch of triangles. It's not what it looks like, right? We plotted it yesterday. It's nice and smooth. It's got this little kind of curvature to it. So if you kind of make it nice and curvy through the maxes and mins, it's more of a straight line type thing going through the midline, but then it should, kind of do something more like this. And once you've done a few of these, it's easier to make it look right. I'm not an art teacher, but at the same time, you can do better than triangles. So it should look something kind of sort of like that. Okay, that's the graph of 3 cosine 4x plus 1. Okay, so let's try one more with a phase shift. See if we can do that. Okay, and I'm going to change it. We'll do a sine instead of a cosine this time. All right. Okay. So let's try. So we'll do 2 sine 1/2 x plus pi minus 3. And we're going to start the same way we did the last one. We got to identify amplitude, period, phase shift, vertical shift. And this one does have a phase shift, like I said, but it's not pi. So be careful. We'll explain here in a minute. So amplitude. What's the amplitude? 2. Period. Careful, it's not 4. What's the B? It's minus 3. I think you just said it. What is it? 4 pi. Okay. Remember, it's 2 pi divided by B. Okay, so maybe I can just write this out for you. So B is equal to 1/2. So the period is 2 pi divided by 1/2. Well, dividing by 1/2 is the same thing as multiplying by what? 2, right? So it's 4 pi. Okay, so amp is 2, period is 4 pi. Phase shift. Well, got to do something first here. Exactly. We got to factor a little bit, because if you look at the first general equation I showed you, there is parentheses after the b. So this should be x plus the phase shift once we've factored out the 1/2. So I can move this over. So it should actually be x plus what? Yeah? 2 pi. Okay? And always just do a quick double check in your head. If you multiply those back together, does it work? 1/2 times 2 pi gets you back to pi, right? So you did it right. Okay, so the phase shift, another thing to be cautious of here. In the original equation, did you notice how it said minus c? And I have a plus 2 pi. So what is the actual phase shift here then? Minus 2 pi, right. I always just pray there's not a phase shift with these. They're way easier if there isn't. But that's what you got to do. Yep. And then vertical shift. I think I heard someone just say it. -3, right? And that one, you don't change the sign, right? Vertical shifts, it's always the same sign. So, all right, so here's what we got to work with. We're going to try and do a graph of a sine. Amplitude is 2. Period is 4 pi. Phase shift is -2 pi. Vertical shift is -3. Okay? And we're going to start the same way. We're going to make that little corridor. Where's the midline? Use the amplitude up and down to kind of fit that in. See where we're starting here. Okay? So, okay. So, vertical shift is kind of where we need to start, right? That tells us where a midline should sit. So where have we got a midline this time? -3. Okay. So down here at -3, there's where the middle of the wave is going to go. All right. So where do the maximums and minimums sit? Let's start with the maximums. So -1, because the amplitude is 2. And where are the minimums going to sit? -5. Okay. Okay, so our whole wave is going to be caught in there, right? Okay, so the next thing that we're going to do then is our anchor point. Okay? So, sine, when x is 0, what are you doing? Take a look at your graph. It's at 0, right? Okay. So, in this case, my 0 would be here at -3, right? But I've got a phase shift. I got to move that point back 2 pi. And that's where it actually starts. Okay? So, before I can do that, I got to put a scale on this thing, on the x-axis. Okay? So to know exactly, okay, where do I need to move it then, right? 2 pi, so how far is 2 pi? How many boxes are we talking here? So, period's 4 pi. What do you suppose each box should be to make maybe a half a pi? That sounds pretty good. So, half pi, so here's pi, 2 pi, 3 pi, 4 pi. I'm getting up to 5 on mine. So, yeah, that should give us plenty of room to do what we need to do. Okay, so we need to take that point, move it back 2 pi. So it's going to scoot back to there instead. Okay, and then we'll get rid of this one. Okay, and then a period should put another point on the midline, right? So go a period ahead of this point, and where should the next point be on the midline? At 2 pi, right? And then 2 pi, if you have the room, or 4 pi, I'm sorry, rather, past that should be at 6 pi. So if you have 6 pi on yours, you can plot that one too. Mine, I'm just a little bit, well, I guess my 6 pi would technically be here, right? And then if I go back another 4 pi this way, I'd be at negative 6 pi, which would technically be like right there, I think. Yeah, so you might have room for some other ones on there. Okay. Now, here's the thing about sine, though. When you do one period of sine, it doesn't just cross that midline when it starts and when it ends. It crosses it in between, too, right? So, like if here's my starting point for sine, here's one period. Okay, notice how we also have this guy, right? Halfway. So, and it's important to know, because it would make a difference when you graph it, it's important to know through that midline, is it going up through the midline or is it going down through the midline? When sine starts at 0, is it going up or is it going down? It's going up. So all of these little points that I pointed here are going up through those points, right? So what I do is I kind of put little segments that show me going up, going up, going up. Just so I remember those are the going up points. And then because of the symmetry, halfway in between each of these points should be what? Going back down, right? So at negative 4 pi, going down. That point that we erased is actually technically there. It's just a going down. And then at 4 pi, it would also go down, right? And so now, knowing all of that, we can plot our maxes and mins, right? Shouldn't the maxes and mins be halfway between all of these, like we talked about before? And when the two are heading up, maximum. When the two are going down, minimum, right? They kind of show you where those maxes and where those mins should be. So you can go through and you can put all of those on here now. So, like, maximum there, minimum there, maximum, minimum, max, and min, like that. And then it's this connect the dot game again, and you got it. Okay. So it ends up looking something kind of sort of like that. So that is the graph of 2 sine 1/2 x plus pi minus 3. Okay? But that phase shift can make it kind of tricky. Okay? So just be careful with that. But other than that, it's the same kind of gist as the last one we were looking at. So, okay. And then the last thing I want you guys to be able to do, and then I will be done, I promise, is I want you to be able to, if I give you a graph, can you then tell me what the equation of it is? So kind of work backwards this process we just talked about. And these are actually a little bit easier to do. Because as long as you can find the amplitude, the period, the phase shift, and the vertical shift off of a graph, then you've got all the information you need to write the equation for it too. Okay, so alright, so let's say this is our wave. Put some scale on it here. Okay, that should be enough. So just by taking a look at this thing, can anybody tell me any one of those four things that we want? Amplitude, period, phase shift, vertical shift. Do you see any of those in there? What do we got? Vertical shift is actually not one. What do we look at for a vertical shift? Yeah? It's 2.5. We look for that midline, right? So that would actually be the first thing that I would do. Try and pinpoint where that midline is. And this one, it's not a nice, neat number. Well, it's sort of. It's 2.5 right through here. And that midline should be exactly halfway between where the max and the min are, right? So the maxes are at 4, the mins are at 1, halfway is 2.5. So our vertical shift, 2.5. Okay, anything else you guys see in there? Yeah.
Amplitude is 1.5.
Mm-hmm. Yep, that makes the amplitude 1.5. Good. Okay, we still got period and phase shift. Yeah. Period is pi. Good. And now here's the thing. The phase shift, it depends. Exactly. It depends on whether it's a cosine or a sine. It would be something different depending on which one it was. So I'm going to say let's go with cosine. Okay? So if assuming it's a cosine, what would be our phase shift then? Yeah. Pi over 2. Mm-hmm. Good. And with a cosine, what are we looking at to determine the phase shift? Yeah, the maximum, the crest. This one has a max right here. Normally it would be here, right? So how far over did it move from where the maximum normally sits for a cosine? Pi over 2. So its phase shift is pi over 2. All right, so can we take all this information, pull it together, make an equation? The only thing we're going to need to alter here is if the period is pi, what does that mean the b had to be? Is it 1/2 or 2? 2, yeah. 2 pi over 2 gives you pi. So b would be a 2. All right, so the b is a 2. The amplitude, the a is a 1.5. Phase shift, that's your c, that's pi over 2. Vertical shift, that's your d, 2.5. All you got to do is drop those four numbers into that first equation we looked at, and you got it. So something like that, then. And sometimes, like when you look up answers in the back of the book, they're going to do this, just so you are aware of that. They're going to go 2x minus pi. And what did they do? They just distributed the 2. Yeah, same thing though. Okay. So, all right. I think that's enough to get you guys going. Your assignment, I'm going to add 2 because the assignment doesn't have you actually graphing any of these by hand, and I want you to do that. So, on a separate sheet of graph paper, and maybe you do these first. Might not be a bad idea. I'd like you to graph f of x equals 4 cosine x minus pi over 4 plus 1, and g of x equals sine 3x plus, whoops, that should be parentheses c, plus 7. Okay, on a separate sheet of graph paper. The rest of your homework you can do on line paper, and it's not a big deal. Okay, but on a piece of graph paper, these 2 graphs, and then so jot these down somewhere right now, real quick, because then I'll put up the calendar so you can see the rest of it. But that's going to be in addition to what's out of the book.